Okay, this video is going to take us from from continental drift to plate tectonics. So continental drift was Alfred Wegener's hypothesis, and when we take a look at what we've done so far, is we have created Pangea by taking a look at fossil remains and by taking a look at glacial deposits and striations. And we used a simulation to kind of put everything together. And this is what Alfred Wegener used for his hypothesis. The problem is he said at one point in time everything was together, but he couldn't come up with how they came apart. So when we take a look at this, we'll go back to the idea that we had Pangea about 245 million years ago. And then it started to break up, and then we had Laurasia, which was to the north side, Gondwana, or sometimes called Gondwana Land, to the south, and it continued to break up. Still no real mechanism. But in the mid-1900s, we as in people, started mapping the oceans. And when we started taking a look at the oceans, we found some things, and they were called mid-ocean ridges because most of the time they were found in the middle of the ocean, and it's actually the first ones that we found were in the middle of the ocean, and that's how the mid-ocean came about. They're not necessarily always in the middle. But that helped us understand. That was the key tipping point. As they started mapping and finding out more and more and more about these mid-ocean ridges, two things came into play. One is that as you go out from the middle of that ridge, the rock got older. And the second part is the Earth's, they found out that the Earth's, as this rock hardened, it took the magnetic poles, and we found out that sometimes the North and South Pole reverse. So by taking a look at this, they found out that everything to one side matched up with everything to the other, so that this ocean was getting bigger and bigger and bigger. So we had two things. One is the age of the rock, and the other one is the magnetism of the rock. And as we take a look at this, there was some unique things that were taking place about this time. And one of them is we are trying to put cables across the ocean. And some of you might think it's weird, but nowadays, if you are on Facebook, and I have a college buddy who's in Germany, as we communicate, a lot of people think it gets shot up into the air and back down. Well, there's cables that run across the ocean floor, which is really weird, and that's a whole lesson upon itself. But how they would roll these cables out, they could tell what the makeup of the ocean was, because if it got deeper, more cable would go out, and if it went up, less cable would go out. So that was another part of the way on how they started to take a look at this. So things that they've also found were some trenches. And this was that idea that if the oceans were getting bigger, that would lead us to believe that the Earth was getting bigger and bigger and bigger. Well, we didn't necessarily think that was happening, but what they found was when they found trenches, if the ocean was getting bigger, then that means that some of the ocean was going down below. And it was being recycled. A lot of times people want to use the term, this particular slide uses the term destroyed at the ocean trenches, but it's going to get recycled and it's going to show up again later. Okay. So plate tectonics is now a theory. So now we have the idea that our oceans are getting bigger. We have mid-continental, mid-ocean ridges where the ocean, new oceanic crust is coming into play. We have trenches where we think oceanic crust is being recycled. And this is how our tectonic plates can move about. So we don't necessarily have the mechanism yet, but that mechanism we'll start talking about when we get farther. But now we have a theory. So we've gone from a hypothesis to a theory. Okay, and when we take a look at plate tectonics, this is going to tell us that the Earth's crust is broken up into 17, I'm going to say 17 major plates. And the reason why I call it major plates is because around these plates something is happening. And just because they're major plates doesn't necessarily mean they're big plates. Like right here off the western coast of North America is the Juan de Fuca plate, and it plays a large role in what's happening like in Washington and in this area. But it's not a very big plate. The Caribbean plate is not that big. The Cocos plate is not that big. There's many smaller plates. I'm not going to expect you to memorize them, but if you ever have to guess the name of the plate, just think about what it's sitting on, like the Eurasian plate, the Pacific plate, the Australian plate. Okay, you get the point there. So now with plate tectonics, we have our crust broken up into different size plates. And a lot of times, depending upon what map you look at, some of these plates aren't going to be as well defined. One weird one is the Indian plate and the Eurasian plate. Sometimes they put them together and they are not together. As we'll take a look at in the future, they are two distinct different plates. So, and at these plate boundaries, unique things are going to happen. And we have three types of boundaries. We have it when they come together. That is called a convergent boundary. We have it where they go apart. That is called a divergent boundary. And we have it when they go past each other, and that is called a transform boundary. So we have three types of boundaries, and that's what the next video is going to be about.